In this unit, we're going to be talking about conversion, surface area, and volume. So meaning that we're going to be applying some of the things that you had learned in Workplace 10, as well as the different things that you had done in grade 8 and grade 9. Now, of course, you had done surface area and volume in grade 8. You had done some more surface area, as well as moved on to surface area of composite objects in grade 9. And then you would have done a little bit of area and such in Workplace 10. So our outcome is to have an understanding of both SI and imperial units. So we have to have an understanding of both. Then we connect with linear measurement, our surface area volume, and measurement between and within the measurement systems. So we have a whole bunch of different indicators. And to be able to understand your mastery, it is split into two different sections. For example, the first one, which I only do in one section because it's so closely tied together, but you want to be able to do questions that involve measurements and conversions, having an understanding about comparable units, for example, your yards and meters, and then being able to verifying your conversions. And then the second part of it, being able to have an understanding of your surface area and your volume. So being able to calculate it, determine unknown measurements, and be able to solve different situational questions. So section 1, we talk about just conversions. Now there's two types of main measuring systems. There's the Imperial and there's the System International. The Imperial System uses old measurements and reference in order to make sense of the units. So this is the one that is primarily done in the United States. Of course, ours is the System International. The imperial unit of an inch, the abbreviation is IN. The referent that is used, so the thing that is usually used to calculate it, is about your thumb length. Of course, if you delve into that deeper, saying that everyone's thumb length is the exact same is very wrong, because they're not. And that's one of the main reasons why the imperial system is so flawed. Same thing with the foot. It's your foot length. Well, you can't say that one person's foot is the exact same size as the other person's foot. Or a yard. The arm span. Well, that's still not. Or a mile is a 20-minute walk. So the reference are just kind of a rough approximation, but they are based off of very common things. For example, back in France, there were some different things where dealing with measurements and weights, but you would always use the king's weight or the king's arm length for measuring. I think it was a French king's arm span or arm length was the yard. But as soon as you went into Germany, their king's arm span was a different size. So merchants were doing different things, and it just becomes a huge issue. And that's the reason why the System International was invented. But we still have to have an understanding because we are in Canada and we have to have a good understanding of the imperial as well as its conversion into the system. So a few main characteristics for conversions, that 1 foot is 12 inches, 1 yard is 3 feet. So if 1 yard is 3 feet and 1 foot is 12 inches, that means that 1 yard is 36 inches. 1 mile is 1,760 yards, and 1 mile is also could be classified as 5,280 feet. We will be using proportional reasoning in order for us to be able to convert. I'll review proportions as well as show you a much faster method known as dimensional or unit analysis. So if we want to convert 7 yards to feet, using proportional reasoning, we have to find out that 7 yards is how many feet. We don't know how much it is. What we're going to do is we're going to use a conversion that has both yards and feet. Well, the one that has yards and feet is this one. 1 yard is 3 feet. Now you'll notice a few key characteristics. I have the yards set up on the same, both in the numerator, and the feet set up in the denominator. What this allows us to do is use cross multiplication. And the cross multiplication just goes like this. 7 multiplied by 3 is 21. X multiplied by 1 is x. So the x value is 21. Really nice and quick. So that means that 7 yards is 21 feet. I prefer, though, using dimensional analysis because dimensional analysis can be done very quickly. The way that you set it up. So I should make one note. The cross multiplication only works when you have an equal sign in between. But proportional reasoning uses our understanding of fractions in order to do things quicker. At least in my perspective, it's quicker. We're going to still use the same proportion or same conversion. The only difference, though, is we're going to set it up as a fraction. We're going to be multiplying fractions. So 7 yards is the same as 7 yards over 1. Now, 1 yard, because we're dealing with fractions, what we're going to do is we're going to set things up so that we can cancel things off. This is the great way to help us deal with units, and it's the primary use or primary thing that I use for Foundations 20 when we do a whole bunch of conversions, as well as any other course, especially in science. Using proportional reasoning or using our dimensional analysis will go extremely quick. So because we have yards on the top and we have yards on the bottom, they would cancel off, leaving us with only feet as our unit. 7 multiplied by 3, because multiplying fractions is numerator by numerator, is still 21. Our unit is feet. 1 times 1 is obviously 1. So both methods are fine. I'll show, again, proportions one more time. 7 yards, we're going to convert to inches. So 7 yards is a certain amount of inches. So we're going to use a conversion that has yards and inches. Well, the one that has yards and inches is that 1 yard. When we use proportions, we have yards on the top, and therefore we'd have 36 inches on the bottom. That means we can do our cross multiplication. X multiplied by 1 would be x. And 7 multiplied by 36 is 252. By our dimensional analysis, I still say that it goes faster. 7 yards, well, within 1 yard, because it says 1 yard, it is 36 inches. And 7 times 36 is still 252. Because the yards cancel off. The reason I so strongly encourage you can do proportion. I just find that it takes a lot of time. At the same time as in our second example, we'll see some more key characteristics as to why dimensional analysis is in my opinion, a superior method. You may be going through an understanding, or you may think one way. For example, you may know that you just have to take 7 multiplied by 36 and you get 252. Great. The reason I prefer dimensional analysis is because it never steers you wrong. You may come to situations where you're thinking, oh, do I have to multiply by 12 or do I divide by 12? Well, this 7 yards over 1 guarantees that you will never do the wrong operation. You will always treat this as a multiplication. The other reason why the dimensional analysis is superior is if we're trying to do multiple conversions. For example, if we want to convert 62 inches to feet and inches. Well, I'm going to go away with without having to use the proportions. I'm going to stick with dimensional analysis because I strongly encourage you get familiar with it so it stays in your head. We're going to convert 62 inches into feet and inches. So it's like saying, okay, I'm so tall. Because 62 inches is a relatively good height. So 62 inches, I set up 12 inches in 1 foot. This means I'm going to take the 62 and multiply by 1. The 1 multiplied by 12. Inches would cancel off. This part you wouldn't necessarily need to write, but it's a good key part to have. 62 divided by the 12 is 5.16 repeated feet. But that's not feet in inches. That's 5.1666666 feet. We want feet and inches, so we need to find out what fraction of the foot is this 1/16th, or sorry, 0.16. This also means that we have 5 full feet. So if we want to say, oh yeah, we are 5 foot what? We can say it's immediately 5 feet. Then we can use another dimensional analysis and just go 0.16666 feet, and we're going to convert that into inches. And because we have this 5.166 in our calculator, all we're going to have to do is subtract off the 5. And then we're left with this amount. So I subtract off my 5. I have that in my calculator already. I multiply by 12, and it works out perfectly as 2. The unit that we have is feet. Sorry, inches. So 62 inches is 5 feet, 2 inches. Even though it may be something that you can do in your head, I would still expect that you're showing your work. It's not a hard thing to show. If we have multiple conversions, for example, going from 62 inches into yards, feet, and inches, we're going to have to calculate it out. Again, dimensional analysis is a great way of doing it. There are 36 inches in 1 yard. So 62 inches. Again, you don't have to write this part, because you could just simply take 62 times 1 is 62 divided by 36. Already have that typed into your calculator. That's 1.72 yards, which means that is 1 full yard. So if we subtract off the 1, we have 0.72 repeated yards. Now we're converted to feet. Well, 1 yard is 3 feet. So I just have to quickly go through it. I subtract off my 1, multiply it by 3. And then I get 2.16 repeated feet. So that's 1 yard, 2 feet. And by subtracting off the 2, I get 0.16 repeated feet. Convert that into inches. 1 foot is 12 inches. Well, that'd be 2 inches left. So that's saying that 62 inches is 1 yard, 2 feet, 2 inches. 62 inches is 5 feet, 2 inches. If we had done this by proportion, we'd have to set it up as 62 inches is so many yards. Still do the same kind of work. 36 inches is 1 yard. 62 multiplied by 1 is 62. X times 36 is 36x. Then we would divide by the 36. And the x would get to the 1.72. Well, then we have to still do that same kind of work. We have to do the 0.72 repeated. Yards is how many feet? Sorry, 1 yard, it's 3 feet. Do our cross multiplication. X would give us 2.16 repeated. It just takes up a lot more time and a lot more work. So this allows us to do things very quickly. Last one about Imperial is Tyson is buying 4 yards of cord to make friendship bracelets. Each bracelet costs needs 8 inches of cord. How many bracelets can Tyson make? If each bracelet costs $2.50, what does cost of friendship? So what we need to do is we need to see, well, how many yards can we make? Or how many bracelets can we make if we have 4 yards of cord? Well, the great thing is, it says each bracelet needs 8 inches of cord. This is another reason why dimensional analysis is so useful. 1 bracelet equals 8 inches. So if we have 4 yards, what we're going to have to do is we're going to have to convert it into inches. Well, 1 yard is 36 inches. But we don't have to be left with right there. Because yes, our yards would cancel off and we'd be left with inches as a unit. The reason why dimensional analysis is so great is we can do dimensional analysis over and over and over again. Those of you that are planning on taking Physical Science 20 will be able to do multiple conversions, sometimes up to 5 different conversions, all in one step by using dimensional analysis. So it says that 1 bracelet is 8 inches. While the inches cancel off, I can tell exactly how many bracelets are, because I just take my 4 multiplied by 36 times by 1, and I know I'm going to be dividing by the 1 times 8. So again, you do not have to write this part, but you would have to write down that the answer is 18 bracelets. Last bit of work is, it says that each bracelet costs $2.50. What's the cost of friendship? Well, this is the first part. The second part is can actually be done by dimensional analysis as well. We have 18 bracelets, and it says that each bracelet, so 1 bracelet, costs $2.50. This allows us to cancel off bracelets as a unit. I know that, of course, I know that many of you can just take 18 and know that you're going to be multiplying it by the 2.50. Some people can't. This is a guaranteed way to be able to do this calculations. It just works. So for his friendship, he needs to spend $45. Now, converting within the Imperial System is not the only thing that we can do. We can also convert within the System International. The reason why the System International is technically a superior unit is because it's much nicer to do. It's simply multiplying or dividing by bases of 10. For example, 1 meter is 1,000 millimeters, or 1 kilometer is 1,000 meters. So really, if I want to find out how many meters something is, if I want to find out how many meters a kilometer, so many kilometers is, I'm just going to be multiplying by 1,000. Same time as if I want to find out how many millimeters I'm going to be using, I just have to multiply by my meters by 1,000. Now, obviously, 1,000 isn't the only one. We use some other key characteristics. For example, 1 meter is 100 centimeters. It's a really nice common one. And we use a lot of things that are System International. Now, we're not going to be focusing on this conversion within the System International because it is so very basic. You're just multiplying or dividing by basically not multiples of 10, but bases of 10. So tying back into our roots and powers, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. Obviously, you can keep on going. But what we do need to do is, because we are in Canada, we need to be able to convert between the Imperial to System International, or from System International into Imperial. These are the conversions that I like using. Sometimes I go a little bit more specific. Just give me 1 second. Yeah, these are the exact same conversions that I like giving on exams. Now, there is a little bit of a sticking point on these. It's because each of these conversions are not using their full decimal values. So you have to be a little bit careful when you're using them. At the same time, when you're checking your work, for example, in your textbook, your answers may be a little bit different, but that's not a problem. So first example, which is a farther drive, 114 kilometers or 68 miles? And by how much? There should be a question mark on there. It doesn't necessarily matter which one we do. For example, we can convert our kilometers into miles or our miles into kilometers. At the same time, the two conversions that we can use, this one or this one, it doesn't matter which conversion we use. I would, in my answer keys for an exam or a unit assignment, I make sure that I have every single conversion. Now, obviously, I usually go with the quickest conversions. You may decide to go with a longer one. Just make sure that your things are correct. And I do take that into account. At the same time, if something's only worth 1 mark, you don't have to do a whole bunch of work for it. All right, so we're going to do 2 things. We're going to convert from kilometers into miles, and we're going to convert from miles into kilometers. But within each of these, we're going to do both equations. We're going to do it both ways. Just to help emphasize that it doesn't really matter which one you do. Yes, the answers may be a little bit different, but that's fine. If we convert 114 kilometers into miles, I could use this conversion. That 1 mile is 1.609 kilometers. That allows me to cancel off my kilometers because one's in the numerator, one's in the denominator. 114 multiplied by 1 would obviously be 114. Dividing by that 1.609, 1.609, leaves me at 70.85 miles. So automatically, we know that 114 kilometers is farther. By how much? Well, that's really quick. 70.85, subtract our 68, is 2.85 miles. But what about if we had used this conversion instead? 114 kilometers. That 1 kilometer is 0.621 miles. Our kilometers would still cancel off, and we'd still be left with miles. But our only difference is we'd be taking 114 and multiplying by 0.621. Again, the emphasis and the reason why this dimensional analysis is so superior is I don't have to guess, am I going to multiply by 0.621 or am I going to divide by 0.621? I know that my units cancel off, and I can know exactly this is going to be multiplying numerators, and I divide by my denominator. 14 multiplied by 0.621 comes out as 70.79. Notice how it's a little bit different by 0.06 of a mile. The entire reason why these two numbers are different is because I'm not giving the entire number here. I'm not giving you the entire 1.609 blah, 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 blah. If I go into more decimal places, these numbers would be indistinguishable. But for a practical application, going to this many decimal places is going to be good enough. So it does not matter whether you use this conversion or this conversion, you would still get everything perfectly correct. So whether you say that it's 2.85 miles farther or 2.79 miles farther, it won't matter to me. I'll have both answers. And as long as you're doing things correctly, you'll have your answers correct. If we did 68 miles into kilometers, we could use this conversion where 1 mile is 1.609 kilometers. The miles would cancel off in this one, and we would just be taking 68 and multiplying by the 1.609. That would be 109.41 kilometers. So again, we're confirming that 114 kilometers is farther than 68 miles. How much farther? Well, if we take our 114 and subtract 109.41, it's 4.59 kilometers. So I just did that in my head, just have to double check. Yeah. Or if we use this conversion, where 1 kilometer is 0.621 miles. 68 divided by 0.621. It's 109.50. So I'll just leave. Yeah, that's fine. I take my 114 and subtract my 109.5. It's 4.5 kilometers. So again, just like over here, it would not matter to me whether you say it's 4.59 kilometers farther or 4.5 kilometers further. Both of them, as long as you're showing your work, you're going to be set. You're going to be fine. Again, the only reason why they're different is because it's not using all of the decimal places. All right. Last example is a truck driver knows that his load is 15 feet wide. The regulations along his route state that any load over 4.3 meters wide must have wide load markers and an escort with flashing lights. So your wide load marker being the one where it's red, white, red, usually says a nice wide load. Red, white, red. I've also seen them with just being a nice solid yellow, wide load. and then you have the vehicle. So we have to determine, okay, if he knows that his load is 15 feet wide, and if he has anything that's over 4.3 meters, he has to have a marker. Sorry, I guess this red one isn't actually a thing. It is just the yellow. There's usually some yellow and black. But anyways, we have to determine it as 15 feet wider than 4.3 meters. So we have to convert it. Again, I certainly encourage you to use dimensional analysis. So where do we see feet and meters? Well, there's one here, or there's one here. Does it matter which one we use? No. 1 foot is 0.3048 meters. So our feet will cancel off. 15 multiplied by that, 0.3048. 4.572. So 15 feet is wider than what this is. So yes. It needs wide load markers. Even if we use the other conversion, that 1 meter is 3.28 feet, it should still come out the same thing. 1 meter is 3.28 feet. It'll still come out to be the exact same revelation. 15 multiplied by 1, dividing by the 3.28, I get 4.573, which is a lot closer, meaning these numbers must be even better for our conversion. I believe that some people use the 0.305, which obviously will make it a little bit less accurate. This one is not too bad. Some people use 3.3, which would make it less accurate. This will allow you to go have some fun.